แต่ตอนนี้ยังไม่ได้รับของเดี๋ยวขอบัตรเชิญงานเลี้ยงตรงนี้แล้วก็เดี๋ยวนะครับพี่หนุ่มเดี๋ยวนะครับผมเห็นโอเค
Oh, a hat. I forgot my hat. That's very good. I'm glad you gave me a hat. I need it. All right, thank you. You're welcome.
Ladies and gentlemen, may I have your attention, please? The program will be starting shortly. We would be appreciate if you could switch your mobile phones to the silent mode. Thank you for your cooperation and attention. So, Good morning. My name is Ann Jambunsi, and I will be the MC of this workshop. On the behalf of the workshop organizing committee, we would like you to extend our warm welcome to our guest, speaker, keynote lecturer, and of course, the all participants here. We appreciate your time to attending this 4-day workshop entitled Genetic Improvement to Reduce Photooxidative Stress in Rice. We hope you find this workshop to be fruitful and engaging. And now may I request our co-organizer, Dr. Apichat Wanawijit and Dr. Eric Murshi to come up on stage for the welcome address and the reporting.
And I hope you enjoy Chuan Sampran. May I have the slide? I have some slides that you may be interested in what I'm to talk. We will briefly introduce why we select this topic. And Eric will go on the background of how we organize this. So it was start 2 years ago in Chiang Mai, where we have the 10th International Rice Functional Genomics. And at that time, we just had big flooding. Probably you know that I think it's time for rice functional genomics to move into stress more seriously. So we picked that theme, the driving the next generation plant breeding. So and at that time we tried to invite a lot of C4 group from Erie, from Germany, all over the world. And I also met Dr. Eric that time. So that's in Chiang Mai. So we think that will Thailand be able to integrate with the C4 group, but it's so far away. So I call it the Blue Sky Project. So I think something that is reachable is how to improve the C3 plants by breeding and using like photooxidative stresses. So we select these topics for the funding by the British Council and TRF and bring you all here. And we choose the conference, the workshop site here because it's very nice. As you can feel, that it's an urban area on the riverside and you cannot escape anyway. So you have to be here 3-4 days with us. And we have moved the workshop there 3 times. So the first time in March, so we was very, very happy. In March we kind of ready. Then in June, so we have the shutdown in Bangkok, and then followed by the coup, and we just feel bored, almost forgot the workshop. Then September, you are here. Very happy. Thank you very much. So that's, this important picture here. Don't show me. ไม่เล่นภาพนี้เดี๋ยวสไลด์ตัวเอริกที่3 third one. So at the Rice Functional Genomics, I want to show this picture. Maybe he forgot this one. So he gave the talk. One more. So the guy that I met him. And I think that one day we would collaborate on photooxidative stress, and now you're here. Thank you.
Okay, thank you Thank you, Apishar, for that welcome. So these workshops are to link people from the UK and Thailand in a productive way. So welcome all of you. It's really good to have you all here, and thank you to Apishar and the organising committee for all their hard work to organise this meeting here. It's a wonderful venue, and I think we're really going to enjoy it. The idea here is really to stimulate collaboration and cooperation between researchers in Thailand and the UK. And it's aimed predominantly at early stage career researchers. So these are people who are highly experienced but also starting out on their careers. So the idea is that this would be something that would continue for many decades. So hopefully that's what will happen. So what are the objectives of this workshop? Well, there are many, and in many ways it's what you want out of it as well. So if there's something that you want out of this workshop, then come and tell us, okay? And we really, as far as the UK is concerned, there are very few people that work on rice and very few people that can even grow rice particularly well. And it's quite common to find people growing rice in inappropriate conditions, for example, in the UK. And it's a shame because rice is such a great model crop for genetics and for physiology. So one thing we can do is to make UK researchers aware of rice as a model crop and to stimulate this exchange between Thailand and the UK. And also to make Thai researchers aware of what's going on in the UK and of research they can connect to, and vice versa for UK researchers. So we'll talk to each other about our research. That's the idea of the workshop, with the talks and discussions. And perhaps towards the end of the meeting on Friday, we'll have some sessions where we try to get ideas going and identify areas for joint collaboration and share resources and expertise where possible. And we'll also go out into the outside and see some rice growing at first hand, which will be a first for many of the people from the UK. And yes, really connecting basic research with applied research. Okay, and the British Council, of course, a big thank you to them for putting the funds, some of the funds for this workshop, and they are the ones who are trying to stimulate connections between different countries. So that's the idea of these researcher links workshops. And you're going to get some more talks from the British Council later in the meeting. Okay, I had some explanation about why we need to look at stress, and I think I have had a few minutes now, right? Yeah, okay. So it's quite obvious that we need to improve yields of crops globally, particularly the major crops like maize, rice and soybean. And we need to increase the rate of yield gain year on year. So is there a pointer here? No. But if you look at this graph of yield against year going back to 1970, you can see a fairly linear increase in. Oh, okay, thank you. A fairly linear increase in yield. This is a paper from Ray et al. Just in PLOS One. We need to improve the rate of yield gain. That means making it not linear. That means increasing the rate of year-on-year yield gain. So at the moment we have a mean yield change for rice of about 1% per year. We need to double that, okay? And that's a huge change. That's a huge ask. If we don't do it, by 2050 we will require extra land in order to meet the requirements of a growing population. And the shortfall for rice is calculated here at about 67 million hectares extra of land. And for wheat it's even more, about 95 million hectares of land. So there's a great need to improve the rate of yield gain. Not only that doesn't take into account the fact that yields will actually, or they should, decline as a result of climate change. So increasing temperature will lead to other factors such as increased drought, increased vapor pressure deficit, for example. And if we don't tackle the fact that we have a predicted yield decline in any case, then we're going to actually have a worse situation. So we need to make crop plants adapt to a temperature change. and adaptation means genetic adaptation to predicted climate change. So in fact, what we have to do is increase yield when yields are predicted to actually decline, which makes it worse. And this is a figure I like to show. This is from Battisti and Naylor. This is published in Science a few years ago. But they did some projected temperature changes going forward to 2050 and about 2090 here. And what they did was to plot a global map, and this is areas in the world showing temperatures where the average temperature is warmer than the warmest on record. So the red areas here are 100% of this land area will have an average temperature that is higher than the warmest yet recorded. So I find that quite terrifying if this is actually right. Okay. So huge problems. The good news from a photosynthesis perspective is that we haven't actually reached the theoretical maximum efficiency of energy conversion in crops. So to cut a long story short, if we take the amount of solar energy reaching the top of a crop, any crop, and then look at the percentage of that energy that's converted into biomass, we find that for C3 plants we have about 4.6%, and for C4 plants about 6%. Okay. So this is a generally agreed upon percentage conversion of energy efficiency. You might think that's very low. I think that's excellent, because we never reach these percentages. Okay. If we do a calculation of energy conversion in the field, we find that in fact we get about 1 to 2% on average, which is much lower. If we really push it, we can go up to maybe 3%, 4% for C4. Why is this? Well, we're not really sure, but a major factor is the fact that plants are not well adapted to their local environment. So we see a much lower efficiency of energy conversion. And this is where abiotic stress comes in. Okay. So abiotic stresses are a reason why we are well below the theoretical energy conversion. If we were actually at that theoretical maximum, there'd be a bigger problem, but we're not. So there's a lot of promise in making plants more efficient in their efficiency of energy conversion under suboptimal conditions. Okay. That's why I'm optimistic about meetings like this, so we can make a difference. Okay. So I'm just looking at the places people are from the UK in this meeting, and this is a map of the UK. And last night I quickly plotted out the positions of people. I hope I haven't missed anyone here. So we are a contingent, a team, if you like, from the UK, scattered across England. There aren't any from other parts of the UK, but we're fairly widespread. We have a couple of people from CSIRO in Australia who are still officially UK researchers, come a long way. And we have Aryo Feldman, who's from still UK, but from Malaysia at the moment. Okay, I think that's all I want to say. Thank you.
Thank you, Dr. Murchie. So after this, the welcome address, we actually should have representatives from British Council and Thailand Research Fund. Without them, we cannot have the workshop today. So, but representatives from both organizations cannot come to join us today. So, but British Council sent the welcome address from British Council to us, right? We will have the video message for about 5 minutes.
The British Council is the United Kingdom's international organisation for educational and cultural relations. Established by Royal Charter as an independent organisation, we operate in more than 100 countries countries worldwide.